Hi everyone, welcome to the lecture on ordinary differential equation. In this video, we are going to discuss this interesting example. This is the question for you. So pause the video, try this example, and after getting the answer, write your answer in the comment section. And then cross verify it. I will explain how to solve this example stepwise. Sometimes we are getting the correct answer but not with the correct step, and sometimes we are using the correct method but because of small mistake we leading with the wrong answer. So cross verification is important. So let's see how to solve this example. Here we have given differential equation which contain log. So try to use the properties of log. So here log y minus log x, we can write log of y by x. So our given question is, here our question is x dy by dx equal to y in bracket log of y minus log x plus 1. So use the property of log here. So we can write it is a log of y by x plus 1. Now see, we are getting y by x, and when we are getting the y by x, when it is a question of homogeneous function. So here it is a single y, but left side x if we shift in the right side, then we will get here y by x. So here the left side is x dy by dx. So this x I will shift in the right side. So multiplication shifting will be divide. So we will get dy by dx equal to y by x in bracket log of y by x plus 1. Now see here, clearly we can see that it is a function of y by x. So obviously it is a homogeneous function. Once we get the idea that it is in the form of y by x, so just put y by x as a new variable. So here I will write this y by x is nothing but new variable. Suppose it is a v. So we will get y is nothing but x into v. So when we are converting y as a x into v, so we have to change this term. It is a dy by dx. So differentiate this term by x. So derivative of left side is dy by dx equal to right side, apply the product rule because x is a function of x and v is also dependent variable. So it is also function of x. That's why product rule you have to apply. First term as it is, derivative of second term plus second term as it is, v as it is, derivative of x is 1. Put this value in this term. So here we have to put this term. So dy by dx is x, dv by dx plus v. So here x dv by dx plus v. This is the left side. Right side is v plus log v plus 1. So here v in bracket log v plus 1. Now v term, here it is a v. So we have to shift that v in the right side. So you will get x dv by dx equal to, already there is a v log of this term. So I will multiply this v in bracket. So we will get v log v plus v. 1 into v is v, and this plus v shifting will be minus. So minus v is there. Now plus v minus v is 0. So here x dv by dx equal to v log v. Now see here, it is simply the question of variable separation now, because here it is a v term. So this term you have to shift in left side, and xx term you have to shift in the right side. So we will get 1 upon, this is in the numerator, so shifting is divide, v log v dv equal to dx, denominator shifting will be multiply, and this is in multiplication, we will get in the denominator. Now variable are separated, so the next step is integrating both sides. So take the integration both sides. Integration of dv upon v plus log v equal to integration of dx upon x. And if we get the idea it is, we are getting answer in the form of log, so obviously we have to take integrating constant in the form of log. So both are getting in the form of log, that's why I will write the constant in the form of log. Now see here how to solve this term. If we consider log v as a t, the derivative of this term is 1 upon v dv is nothing but dt. So here log v, if we consider t, so dv upon v is nothing but dt. So put this value to solve this integration. So we will get dt upon t equal to integration dx upon x plus our integrating constant log c. Now it is a simple 1 upon t integration is log t and right side is log x plus integrating constant log c. T is nothing but our log v. So we have to put here log v. Log x plus log c is nothing but log of x into c. So first I will apply here the property of log and then we will put the value of t. So here log t as it is and right side become log of x into c. Taking antilog on both sides because both contain log, so t equal to x into c. Now put the value of t. T is nothing but our log v equal to x into c. Here v, again we can put the value of v as a y by x. So here v, actually our v is nothing but v is our y by x. So v is y by x and we want to always answer in the form of x and y because our main question is in the form of x and y. That's why we have to write whole term lastly in the form of x and y. So v is y by x equal to c. So this is our final answer. But because option is not contain this log term, so take anti-log again both the side. So taking anti-log on both sides, so this log will be out. So we will get y by x and here is not log. So when we are taking anti-log, so this term will be e power x into c. Now divide x, shifting will be multiply. So y equal to x e power x into c. Hence this is our final answer. That means the option A is the correct answer. सो आई होप आपको भी यही सेम आंसर मिला होगा अगर आपने ट्राई किया होगा क्वेश्चन को. तो इसी तरह से यू कैन सॉल्व द ऑर्डिनरी डिफरेंशियल होमोजीनियस क्वेश्चन and it is very simple to understand once we get in the form of y by x question. So obviously we have to put y by x as a v. अगर नाम से याद नहीं भी रखोगे तो सेम ब्रैकेट जब लिखता है तब आपको क्या करना है, न्यू फंक्शन पुट करना है. दैट इज द स्टेप ऑफ रिड्यूसिबल टू variable separation, and the same here that we will get y by x, so put as a new variable. Sometimes आपको किसी और क्वेश्चन में डाउट हो सकता है, तो what you have to do, just send your question in the comment section or in telegram group, otherwise Instagram, so that particular question we will try to cover in our next coming video, so that you will get a clear idea how to solve that question and you will able to clear your exams. Thank you for watching.